Okay, simplifying radicals with exponents and variables. So here, if we have the square root of x squared, well, a square root undoes a square. Basically, they cancel each other out. So it's just simply going to be x. Another way to think of x squared is x times x, right? And if we have a pair, we can take that outside of the radical as 1. So we're left with just x outside of the radical. Similarly with y cubed, or sorry, y to the 6th, that is y times itself 6 times. Okay, so we've got 3 pairs of y's, so each of those goes outside the radical just as 1y. So that then becomes y times y times y outside the radical, or y cubed. Okay. So basically you should see the pattern that anytime we have a variable, or a number for that fact, to a even power, so like we have here p to the 4th, when we take it outside the radical, we're just going to divide that power by 2 essentially. So it's going to become p squared when it's outside the radical. X to the 6th is going to become x cubed when it's outside the radical, and y squared is going to become y. So then we can of course involve numbers in this. Remember, these are all just being multiplied by each other. Okay, so same here. We've just got 4 times x times itself 4 times within the radical, and then times y times itself twice in the radical. So what I mean by that is we've got 4 times we've got this, right? So this is a pair, this is a pair, this is a pair. They're all going to go outside as 1. And then we know the square root of 4 is 2, right? So this is going to become 2 outside the radical. We've got x times x, and we've got times y. And that x times x is x squared. Oops, times y. Okay. I think it's important to look at if we have an odd exponent. So let's make this 11 instead of 10. Okay, so we've got 25 times c to the 8th times d to the 11. So 25, of course, the square root of 25 is 5. We know c to the 8th is going to become c to the 4th when it comes outside the radical. D to the 11th, so 11 is an odd number, right? D to the 11th is the same as d to the 10 times d, right? D times itself 10 times, and then times itself again makes 11 times. So we know when we take this outside of the radical, that it's going to become d to the 5th, right? So this is all underneath the radical right now. When we take it outside, it'll be d to the 5th, and then that last d will just remain inside the radical. Okay, so that square root of 25 became 5. The square root of c to the 8th is c to the 4, because that's an even power. We just divide the power by 2. D to the 10th becomes d to the 5th, and then inside the radical we've still got this d left over because we had an odd number, an odd numbered power to start with. And it works the same with numbers. So for example, if you have 2 cubed within your radical, we know that's the perfect square, 2 squared times 2, right? So 2 squared, when we take that outside the radical, that's a pair. That's going to become 2. And then we've got the square root of 2 still left within the radical. Another way to visualize that is if we write that as 2 times 2 times 2, so we've got a pair of 2's, so that 2 comes outside, and we've got 2 left. Okay,